Okay, so we are discussing the data link layer. In the data link layer there are two protocols. First one is your flow control protocol that we have not discussed till now, and second one is your error control protocol. Now in the case of the error control protocol, we have discussed a different type of error detection procedure. And why the error detection procedure is necessary in the data link layer? Because whenever we are sending a packet of data from node A to node B, and during the transmission, this is the unreliable transmission medium, and whenever the data packet is being sent from node A to node B through the unreliable transmission medium, then what happens? The intended data may be changed in its course of transmission. To avoid such error in the transmission, error detection or the error checking method are used in the computer networks that ensures if the received packet is error free or not. Okay, so the most commonly used methods are: first one is your single dimensional parity check. That means what this is called one dimensional parity check, and that method we also discussed in our previous lecture. And second one is your multi-dimensional parity check, or you can see that the row and the column, that means the two-dimensional parity checking method. Okay, and third one is your checksum. This is a checksum method. Okay, so in the case of the checksum method, we are try to there is some sort of limitation in the single dimensional parity checking method, and this limitation is overcome by the with the help of this multi-dimensional parity checking method. Then we discuss another method. Now is the checksum method. So the checksum method has some its own advantages and own disadvantages. So this is one type of method which can detect the error, not it can correct the error, it can detect the error. Okay, so this is one of the method by which we can detect the error from going from one node to another node. Okay, so now what is the checksum? So next, so we have also previously discussed the cyclic redundancy check method. So in the case of the cyclic redundancy check, you have seen that the cyclic redundancy check is a very good method through which we can also detect the error. But this is also another method, a checksum method, and this method is also used to detect the error. So we have not till now discussed the error correcting code. So error correcting code is the Hamming code, so that is quite complex. We will discuss try to discuss this method in the next class. So this is the last method we will discuss, that is the error detecting method. Now this checksum technique, this technique is used to ensure data integrity, to ensure data integrity at the receiver end. At the receiver end, when data is being transformed from data is being transferred from source to destination. Okay, so the data is being transformed from source to destination. It is the sum of data bits calculated from the digital data. It is an error checking method which ensures the data integrity before going ahead. Okay, so it is used to ensure the data integrity. The what do you mean the data integrity? Data integrity is a method by which we can ensure that there is no error of the data whenever it is going from sender to the receiver side. Okay, so sender to the destination, from the sender to the destination. So data integrity. So data integrity is very important term. You can also search what is the actual meaning of this term, but I am in this context in the networking concept of the error detecting concept. Okay, that means the data must be kept intact whenever it is going from sender to receiver. The receiver does not get any kind of erroneous code or erroneous data from the sender side to the receiver side. So the data integrity must be preserved, or data must be preserved. That is the called the data integrity. Okay, so checksum method is a small definition of the checksum method. So before going into the checksum method, one must understand the boolean value, addition of the boolean value. That is the main backbone of this checksum method. Okay, so the addition of the boolean value, all of you must know that the what do you mean by the addition of this boolean value. Okay, that how the boolean algebra is used to add the digital value. So the addition of boolean value. Okay, in the case of the addition of the boolean value, all of you know, so this must be remembered: 0 plus 0 tends to 0, 0 plus 1 tends to 1. Okay, 1 plus 0 also tends to 1, and 1 plus 1 tends to 0 with a carry 1. Okay, just like we have add this 98 plus suppose 05, so somehow one carry is being generated. Okay, this 2 bit is not suffice to result to reflect the result. A carry bit is being generated in the decimal number, so that's why this is a carry bit is being generated. Okay, so this is the main backbone to, or the main method used for the checksum error detecting. Okay, now the checksum technique. Now the checksum technique steps. I'm detecting the checksum technique steps. Okay, this is the steps that the sender node following tasks are completed. The first one, divide the data into equal size segment. That means whenever data is being transformed from the sender side to the receiver side, the data is not a small data, that means the 8-bit data or 16-bit data. It is a bunch of data, okay, that is being transferred from the sender side to the receiver side. Length of the data is very much high, and whatever may be the data format, that means the image, video, text file, whatever may be, that is being converted to the corresponding 10 format, because computer only knows the 10 format, and the data is being divide into equal size segment. So first step is divide the data. So divide data into equal segments. Divide data into equal segments. Now I have taken here one data or segment of data for the purpose of this understanding. So we have taken this data as, suppose data is segment of data is 10 11 00 10 11 00 11. This is one divide data, and this is second one is 10 10. Okay, 10 11, and third one is 01, 1 minute, 01 011 01 011 010. Okay, and last one is 11 01 1101 0101. So we have this data is to be transferred. We have this data that has to be transformed from the sender to the receiver, and we have divide the data into 1 2 3 4 5 6 7 8 with 8-bit data, equal segment of 8-bit data into 4 segments. Okay, so this is the first step we require in our calculations. Okay, and next step is to add the data. Next step, the second step is add all the data. Add, 1 minute, add all the data. Wrap around extra bit. Wrap around extra bits. So this is the second step, add all the data and wrap around extra bits. So first step is divide, this is the divide the data into equal segments. So we have taken equally divide the data into 8 bit, all data is 8 bits. Okay, and fourth segment, that is fourth segment of data. Okay, and second one is add all the data and wrap around extra bits. Okay, so add all the data and wrap around extra bits. So what do you mean by this, we will understand in the next slide. Okay, so this is the first data 10110011 and 10101011, these two data I am going to add these two data. So first one is 10110011 and second one is 10101011, second one 10101011. Okay, so I am just add all these two, I am just add these two. So if you just add these two, this 110, okay, and with a carry 1, this triple 1 1 with a carry 1, so this will be your 1, second one 1, second one 1, so 4 consecutive 1, then 0, then 1, then 0, then 1. So the result is there is a carry bit, this is your carry bit, and the result is 0 1 0 4 1 and 0. So this is the after addition, simple addition, boolean addition, we get this. Then add all the data bits, wrap around. Now the wrap around, what do you mean by the wrap around extra bit? The wrap around extra bits means this one has to be added again, this one has to be added again. So if you just add this bit again, so what do you get? We get 1 and 4 consecutive 1 again, 1 1 1 1, so 5 consecutive 1 0 1 0. Okay, so 0 1 0 and 5 consecutive 1. Okay, so we will again add this with this 0 1 0 1 1 0 1 0 0 1 0 1 1 0 1 0. So 0 1 0 1 1 0 1 0. Okay, so I'm just going to add this, I'm going to just 0 1 0 1 1 0 1 0, you have to add this. If you just add this, this is 1, this is 0 1 1 0 with a carry 1 1 1 0 with a carry 1 triple 1 1 with a carry 1 triple 1 1 with a carry 1, this is 1, this is 0 and this is 1. So result is 1 0 3 1 and 0 0 1. So this is your result after addition. So there is no carry bit is there, no carry bit is there, so there is no meaning of wrap around here. So I am just going to add the last one, 1 1 0 1 0 1 0 1 with this, so 1 0 3 1 and 0 0 1 with I am going to add with 1 1 0 1. Okay, 1 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. Then I am going to add this. Okay, now we are going to add this 1 1 0 with a carry 1 1 1 1 1 0 with a carry 1 1 1 0 with a carry 1 1 1 0 with a carry 1 triple 1 1 with a carry 1 1. So the result is this is your carry. So 1 3 0 3 1 0 with a carry 1. I am going to add this again, this carry, this is called the wrap around. Okay, so I'm going to wrap around, this is 1, then again 3 1, then 3 0 1. So 1 3 0 4 1 1 3 0 4 1. Okay, so now the checksum is going to be generated. The final step is generation of checksum. Now the checksum is nothing but complement of this. This complement of this is your checksum. Okay, complement. The third step is complement to find checksum. Complement to find checksum. Okay, so just complement this 0 0 0 0 4 0, after that 3 1, after that 0. Okay, so this is your checksum, 0 3 1 4 zeros. Okay, now this checksum is being sent from sender to the receiver side, because in the case of the cyclic redundancy check we have also sent that the CRC bit is being sent also to the site. So the receiver end following tasks are completed: add all the data and wrap around same as sender node. Add all the data and wrap around the same as the sender node. Okay, 1 minute. So this is your, I am just checking the data, 10110011. So suppose there is no error is being generated. Now what receiver does, receiver does the same steps again up to this. So receiver does the same step again up to this. Up to this means it actually adds all the data. And wrap around extra bit with the same procedure, with the same sort of procedure. It actually adds all the data segment and wrap around extra bits. Okay, so at the receiver side, this is your receiver side. So at the receiver side, receiver does the same step, same whatever data it got from the sender to the receiver. Suppose this is node A, this is node B. So the whatever data it has received at the B, it will get equally divide with 8 bits and add all the data. So the step 1 is same, whatever data it has received, so add all the data and wrap around the as the sender's nodes. Okay, so if I have assumed that no error is being happen whenever the data is being transmitted from the sender side to the receiver side, so this same thing is being generated also from the at the receiver end. So 13041, so 13041. Okay, now what receiver will do, receiver will now ask for the checksum. So checksum is being sent from the sender to the receiver, because in the case of the CRC cyclic redundancy check, CRC bit is being sent from sender to the receiver, and that bit is being the key factor for detecting the error. Okay, so now this checksum, is also as the same as the CRC bit. So the checksum is being also sent from sender to the receiver. Now after wrap around extra bit and addition of all bit, the checksum is being needed. So what is do the checksum is, what is the checksum? 03140, 03140. Now receiver will add the checksum with the result. Now whatever all one. Now whatever receiver do, receiver again complement this result. Now after complement you can see all one. So what receiver will get? Receiver will get all 0. After complement receiver will get all 0. Now if the receiver will get all 0 after this step, then the receiver knows there is no error. And if this result, final result, is not all 0 after complement, if the result is not 0, then the receiver knows that there is some error is being happen from the sender side to the receiver side. Okay, so easily it can find out the error. So that's the way we can find out the error. Okay, so This way we can detect the error very easily. So in the cyclic redundancy check, what happens? CRC bit is being frames from sender to receiver, and this bit is being important to calculate the wherever there is a error is being generated at the from the sender side to the receiver side during the data transmission. Likewise, in this checksum method, the checksum bits, this checksum bit, this is your checksum bit. So this bit is important. So this checksum bit is being sent from sender from the sender to the receiver side, and this is also important. This checksum bit is also important to detect the error, whether there is a error during the transmission from the sender side to the receiver side. Okay, hope you understand this. Thank you.